Hello everyone, welcome to Maths Easy. Here's another possible question that you can get in GCSE Maths. Prove that the angle subtended at the circumference by a semicircle is a right angle. Please pause the video and see if you can figure this out. When you want to check the answer, press play. Now here you can see a circle. Now let's mark a semicircle like this. Now we need to prove that if I start from this end here and this end here and connected those 2 points to any points on the circumference. So let's just go to a random point here. Now we need to prove that this angle here, this one here, is a right angle. We know this as a circle theorem, but let's see how we can mathematically prove it. Step 1. You need to connect the center to this point. Now, we know this is O, so this point is A, this point is B, and this point here is C. Now, this and this, these two are radii of the same circle, so obviously they are equal in length. So if this angle here is xn, because this one is isosceles, this must be x. If this angle here is y, because these two are the same, this must also be y. So we need to write the reason here. AO is equal to BO is equal to CO or OC, because they are all radii of the same circle, which makes ABO and BOC isosceles triangles. So these angles x and y are equal because base angles of isosceles triangles are equal. Now let's pay attention to this big triangle A, B and C. Now we can see this angle here xn, this angle here y, and this full angle here x and y all should add up to 180. Why? Because they are interior angles of a triangle. So let's see how we can simplify this. The two x's are like terms, so that's 2x, and this y and add y, that's 2y, is equal to 180 degrees. Factorize the 2 out, you get x add y here is equal to 180. Divide both sides by 2. So I get x add y is equal to 90 degrees. Now what's x add y? X add y is this angle here, which is the angle that we needed to prove as a right angle. Now, this is one way of doing it. Some people do it in a slightly different way, which is also correct. Let me show you that method now. So even in the second method, up to this point, everything else is the same, but now we do something different. Now, if this is y and this is y, obviously this one here is 180 take away 2y. What's the reason? Angles in this triangle B, O and C add up to 180. Similarly, I know this one here is 180 take away 2x. What's the reason? These three should add up to 180. So we can write the reasons like this. Now, if you think about the sum of these two angles, obviously 180 take away 2x add 180 take away 2y. These two should add up to 180 because angles on a straight line add up to 180. So that's 180 degrees, and you can just do the simplification. So let's do that. 180 add 180 is 360. 360 take away 2x take away 2y is equal to 180. Now move the 180 to this side, move these two to the other side. So 360 take away 180 is 180 is equal to 2x become positive, 2y also becomes positive there, and like before you can factorize. 180 is 2 bracket x and y, divide both sides by 2, cross cross, obviously I again get x and y is 90 degrees, which is the same result we got earlier. So you can use any one of these methods to prove that the angle subtended at the circumference by a semicircle is always a right angle.